What images go through your mind when you think of the end of the world? Asteroids. Perhaps a world war. Climate change, or even aliens. Even if some of these things are realistic, there's a much greater threat lurking beneath Earth's surface that could put an end to human civilization. When volcanoes erupt, they spew hot, dangerous gases, ash, lava, and rock that are powerfully destructive. They can devastate huge regions, as it happened when Mount St. Helens erupted in the United States, or destroy cities like in 79 AD when Mount Vesuvius erupted, destroying the city of Pompeii. But is it possible for a volcano to erupt with a massive enough force that could actually destroy all of human civilization on the planet? Well, volcanoes have come dangerously close to doing just that at multiple times in the past. To better understand the destructive power of volcanoes, we have to look at the Volcanic Explosivity Index. This is a numeric scale that measures the relative explosivity of historic eruptions. The scale is open-ended, with the largest volcanic eruptions in history given magnitude of 8. For reference in regards to how powerful volcanoes can actually get, both the Mount St. Helens eruption in 1918 and the Mount Vesuvius eruption that annihilated the ancient Pompeii would both be classified only as a level 5 or cataclysmic eruption on the scale, which is incredible because the Mount St. Helens eruption released 24 megatons, or 1600 times the scale of the atomic bomb dropped on Hiroshima. But the explosions of Pompeii and Mount St. Helens fade by comparison to the largest explosion recorded in modern history. With a rating of 6 on the Volcanic Explosion Index, the eruption of Krakatoa, or Krakatau, in August 1883 was one of the deadliest and most destructive volcanic events recorded in modern history. It's estimated that more than 36,000 people died. On the 26th of August at 1 p.m., the first of a series of increasingly violent explosions occurred, and at 2 p.m., a black cloud of ash rose 17 miles above Krakatoa. The climax was reached at 10 a.m. on the next day, with tremendous explosions that were heard 2,200 miles away in Australia and propelled ash to a height of 50 miles. Pressure waves in the atmosphere were recorded all around the Earth. The discharge of Krakatoa threw into the air nearly 5 cubic miles of rock fragments, and large quantities of ash fell on an area some 300 square miles. The surrounding region was plunged into darkness for 2.5 days because of the ash in the air. The fine dust drifted several times around the Earth, causing the average global temperature to be as much as 1.2 degrees cooler for the next 5 years. Ships as far away as South Africa rocked as tsunamis hit them, and the bodies of victims were found floating in the ocean for months after the event. The town of Merek was destroyed by a tsunami which was 46 meters high. Some of the pyroclastic flows reached the Sumatran coast as much as 40 kilometers away, having apparently moved across the water on a cushion of superheated steam. Krakatoa was the largest eruption in modern history, but it was not the largest recorded. Going up one more time on the scale of the Volcanic Explosivity Index, Mount Tambora produced the largest eruption known on the planet during the past 10,000 years on the 10th of April 1815. When Tambora blew up, it blasted 12 cubic miles of gases, dust, and rock into the atmosphere and onto the island of Sumbawa and the surrounding area. The volcano erupted more than 50 cubic kilometers of magma and collapsed afterwards to form a 6-kilometer wide and 1,250 meter deep caldera. The eruption produced a giant Plinian column, which is estimated to have reached more than 50 kilometers altitude. Rivers of incandescent ash poured down the mountain's flanks and burned grasslands and forests. The ground shook, sending tsunamis racing across the Java Sea. An estimated 10,000 of the island's inhabitants died instantly. Debris from the volcano shrouded and chilled parts of the planet for many months, contributing to crop failure and famine in North America and epidemics in Europe. Climate experts believe that Tambora was partially responsible for the unseasonable chill that affected much of the northern hemisphere in 1816, known as the year without summer. But if you think that it's not possible to have volcanoes explode with more power than this, well, that is why we have level 8 on the Volcanic Explosivity Index. The most recent of these kinds of explosions took place just 75,000 years ago, and it happened, you guessed it, in Indonesia. It was one of the Earth's largest known explosive eruptions. The Toba catastrophe theory holds that this event caused a global volcanic winter of 6 to 10 years and possibly a 1,000-year-long cooling episode. Some scientists have even suggested that the Toba super eruption was so powerful it pushed our ancestors to the brink of extinction around the time humans were first venturing out of Africa. The erupted mass was at the very least 12 times greater than the largest volcanic eruption in recent history, namely the 1815 eruption of Mount Tambora. Toba's erupted mass deposited an ash layer of about 6 inches thick over the whole of South Asia. A blanket of volcanic ash was also deposited over the Indian Ocean, the Arabian Sea, and the South China Sea. Ice core evidence suggests that average air temperatures worldwide plunged by 6 to 9 degrees Fahrenheit 4 years after the eruption. If you think there is no concern here in the US, you better think again, because many Americans who visit Yellowstone National Park are perhaps unaware that beneath them is a 43 by 28 miles volcanic caldera or supervolcano. The Yellowstone supervolcano, an 8 out of 8 on the Volcanic Explosivity Index, has erupted 3 times over the past 2.1 million years, most recently 640,000 years ago. A Yellowstone eruption would be like nothing humanity has ever experienced. There's enough magma in the volcano system underneath the surface today to fill the entire Grand Canyon 11 times over, or bury the entire Netherlands with 1 full kilometer of molten rock. But what would it look like if the Yellowstone supervolcano would erupt? First would come increasingly intense earthquakes, a sign that magma beneath Yellowstone was rushing towards the surface. Then magma would burst through the ground in a titanic eruption, discharging the toxic innards of the Earth into the air. It would continue for days, burying Yellowstone in lava within a 40-mile radius. A bad day at the park, but the devastation around Yellowstone would be just the beginning. Volcanologists believe the Yellowstone super eruption would bury large swathes of Colorado, Wyoming, and Utah, up to 3 feet of toxic volcanic ash. Depending on the weather patterns, much of the Midwest would receive a few inches too, plunging the region into darkness. Even the coasts, where a majority of Americans live, would most likely see a dusting as the ash cloud spreads. Crops would be destroyed, pasture land would be contaminated, power lines and electrical transformers would be ruined, potentially knocking out much of the grid. That's just the United States. Modeling by meteorologists have found that aerosols released could spread globally if the eruption occurred during the summer. Over the short term, as the toxic cloud blocked the sunlight, global average temperatures could plunge significantly and not return to normal for several years. Rainfall would decline sharply. That might be enough to trigger a die-off of tropical rainforests. It would be the greatest catastrophe since the dawn of civilization. So what are the odds of a Yellowstone super eruption? The good news is they are very, very low. In fact, it's even possible Yellowstone might never erupt again. Scientists estimate that the volcano has about 1 in 700,000 chance of exploding each year, which is absurdly unlikely. Still, as we look back in history, the question about supervolcanoes, as it turns out, isn't whether one could destroy all life on Earth, it's when will it do it again.